Uh, Hello, can you hear me?
Yeah, clearly.
Yes, and can you see my screen?
Yeah.
Okay, so the time is it's time to begin. I think first of all, thank you for everyone to attend this training because I know here for some countries it's late. So thanks for your attending. And today is our first class, and I will introduce some content about EtherCAT communication. And this is our today's content interface and the product protocol introduction, object dictionary, and how to connect our VD3 to our 6V. Okay, so first part, let's check the interface and the value. This is the picture of our VD3E A-type driver. And you can see it's very similar to our VD2 series driver. And here I have already marked the difference ports with red color. First, on the top, CN5 and CN6. This port is used for EtherCAT communication. But in VD2, these two ports are used for Modbus RS485. And CN3, these ports in VD3, we change it to Type-C interface. And this port is used to connect to our PC software. We have a SC tool. And CN2, you can see here in VD3, this is DB15 pin, DB15 port. But in VD2, it is DB44. So this is the mainly difference about the interface between VD2 and VD3. And this is the panel of VD3. And you can see here have two. First list two is the lamp about the CN5 and the CN6 ports. Here I only connect CN5, so this one is light on. And the second number is about the EtherCAT communication status. And eight means operational status. Normally after power on the driver, this status will change from 1, 2, 4, and 8. These parts, the controller EtherCAT master will send command to you can understand it to make our driver in operational status. And then the third number is the operation mode, control mode of VD3E. Here have PP mode, PVPT, homing, CSP, CSB, and CSC. And for this control mode, I will introduce them in the future class in details. And the last two number is the servo status. So you can see here have NF. NF means no error, no fault. And RN means wrong, and RY means ready status. Okay. And this is the wiring. If you connect with 6V, we need to from master connect the Ethernet port to CN5. And if you want to connect more driver, here we need to connect first driver CN6 to the next driver CN5, and one by one, yes. So in this here, CN5 is for in and CN6 is for out. So we can't exchange the wiring order. Otherwise, the communication will have question. And after this wiring, the slave ID will be the select ID will depend on the wiring. So for this wiring, this is our select 0, so, select 1, and select 2, and so on. Okay, so this is the interface panel and wiring for VD3E. And now I will begin to introduce EtherCAT communication. First, first EtherCAT means this Ethernet for Control Automation Technology. This protocol is proposed by Beckhoff in 2003, and this protocol is a high-speed real-time Ethernet communication to meet the high requirements of the modern industry control systems. Yes, and here EtherCAT communication is based on master-slave mode. So you will see in the EtherCAT bus system there are one master and many servers, just like Modbus. And here I have a picture. You can see how does the master and the slave communication. First, the master will send the EtherCAT a frame, and this frame will go through all server all slave one by one, and each slave will process the data of their own frame content in turn. Sorry, here you can understand here. Sorry, here. For example, for select 0 will check the frame, and there will be only a part. A part content is about select 0. For example, master want to read the for example parameter of select 0, and then select 0 will put the parameter to the frame and transform this frame to the next slave. And the next slave, for example, there have some content in frame want to read some parameter from slave 1, and slave 1 will also to operate it. So you can see one frame sent from EtherCAT and go through every slave, and finally go back to the master. This is one cycle, and the cycle time is very fast. Usually you here we set the EtherCAT synchronous cycle as 1 ms, 2 ms, or 4 ms. This is the cycle time about this frame goes root. Okay, and here is some mainly control modes in VD3 position control. We call it as we have two type. One type is CSP, cyclically synchronous position mode, and we also have PP. PP means profile position, and also here speed CSB and torque CST PT, and also we have homing mode. If you see the PDF I sent, you will see in the next class I will introduce this control mode. In details. So here we just need to know how many control modes supports in VD3E. In fact, this control mode is just a standard. It's a standard in EtherCAT under EtherCAT protocol. and the data transfer. So for now we know in EtherCAT we have master and many slaves. So how does the tra tra data transform between master and the slave? Usually we have these two methods to transform the data. We call it as PDO and SDO. Yes, and here have a table. Here I have a table to show the difference between PDO and SDO. It's easy. How to say? It's an easy table. I mean, you can, in fact, you can find more details informations on the internet to about these two transform type. And here I will just easy to introduce these two transform methods. First, for PDO. PDO is real-time process data, but SDO is just usually used for parameter configuration. And you can understand if we compare if we configure some parameter by PDO, and then this parameter will be refresh or update in every cycle. You know, EtherCAT is cyclically running. So, for example, we set the synchronous time as 4 ms, and for example, we configure parameter A and parameter B by PDO mode. Then these two parameters will be refreshed every 4 ms all the time. But SDO is just like here we call it as point-to-point communication. It needs requests and response. It means we need to use some instruction in our project. For example, you execute this instruction, and we will send a read or send a write command from master to slave, and the slave will feedback the information we need. So it is just a little like if you use our 3V or 5V, it's just a little like our eyes instruction, point to point, and yes, and in real time, PDO is more fast, and SDO is not real time. And for data length, for PDO is usually a fixed length. Before the project running, before the program running, when we created a project, we can configure how many parameter we need to put it in PDO by PDO. So after configurates during the program running, we can't change it. So we say it is fixed. But SDO, we have no limits. For example, during program running, you can change the target parameter you want to read or write just by changing the variable in our instruction. So, and also we can change the data length. So for application, usually for some parameter, for example, in CSP control mode, it's a cyclically here. Cyclically synchronous position control. In this control mode, master need to send the target position, target velocity to the slave in every cycle. So so you can see in this control mode, we need to set the target position, target acceleration, deceleration, and the target velocity. Set it as PDO type, because we need to update this parameter in every running cycle. Yes. But for some parameter, for example, you need to change the how to say change some parameter, several parameter. You don't need to change all every time. For example, the homing speed. Homing speeds usually we have two homing speeds. One we call it one we call it as close speed, and another we call it reach speed. So for example, for these two parameters, we don't need to change length all the time. We just change length one time. So for this parameter, we can use SDO to change it. It's not recommended to configure PDO too many parameters, because it will influence our running speed. So we just put some very important parameter, and which required high speed refresh to PDO. Okay, so this is some basis content about EtherCAT communication. How this protocol come from, and this master and slave modes, and how the frame transform between master and slave, and how the data transform between master and slave, and also some control modes in EtherCAT. Okay, and now I will introduce this object dictionary. How to understand this words. Here I have said, for example, if you want to use SDO instruction to read or write some parameter, we need to know the address of the parameter. So object dictionary is you can understand it as a table about the parameter. Okay. We can directly check this table. This is the address range or index of the parameter, and this is the content. Here, for this 2000 group, for this group, this group depends on different factory. For example, Wecon, our product, we will put some our VD3E parameter in this group, and for example, running direction and some monitoring value, for example, motor speed or bus voltage. This parameter is our parameter. So we put it in 2000 group. If you use other brands with this other brand EtherCAT driver, you will see the content in this group is different. But for other group, for example, these two group and these two and and for other group, this group and this is standard group. How to say, the content in these two group is same for different EtherCAT device. EtherCAT driver, for example, here in 1000 from 1000 group is some communication area. So you can see address 1000 is device type, and here we'll display the device you connect. and some arrow register and so on. Here, from 2000, it is some parameter according to the factory. And here for our product, we can see this is rotate direction and some other parameter. And from here 6,000. From this group is standard equipment sub protocol. So the most control parameter about our control board is included in this group. For example, control watt. Control watt is used to set the status of our driver. We can change this parameter to make our driver, for example, from RY change to RN status. RN means wrong status. And in our VD3 manual, you can see all these parameters in details. Here just a part of the parameter show here. And from this picture, you can see this is CSP control mode. You can see for this control mode, usually we need this parameter for input and this parameter output. We need to configure this parameter in our master, in our controller. Control watt, target position, and GL ratio, and also some parameter. And this is for homing mode. It will also have some requirement input and output parameter. Okay, and last I will introduce the communication between VT3E and 6V. First, wiring, just like this. If here, in this video, I only connect one server, so just connect one cable. You can check the video. First, here in this project management, we right-click EtherCAT and click New. Here to add our EtherCAT slave. You will see here we here have many different version of our VD3 driver. And here we need to select the same version of this of our driver. You can check the firmware of our driver in this parameter U2 and 4. For example, you see this parameter displayed 1.12, and then we need to select first one slave to add. And it is displayed here. And if in our software or you want to connect different brand, you can click import and select the slave file to import. For example, you use other PLC. Use other PLC connect our driver. You can import our servo file to their controller and select it. Okay, and the next is PTO configuration. Here, double click the slave. will show the information about the slave, and this is a 6V interface. Usually we can see the process data in slave information. And here you see we have two type. Here is output, and this is input. We can select one group of output and one group of input to do the communication. Here you can see for output we have three group. For input we have two group, and then the parameter, the objects dictionary in different group is different, and this is the default configuration. And how to change this parameter in our program? Usually we can map our variable to these to those parameter. And here, if we uncheck this output group in IO map, you can see the parameter of that group is disappear. And if we uncheck this input group, here will show nothing in IO mapping. So how to change the PTO configuration? First, we need to enable these expert parameters. For this button, you can also see it in codices. And after check it, you can see here we will have another page used for PTO configurate. For now, we are using these two group, 1701 and 1B01. We can click add to add the object dictionary to the group. This is output. Sorry, this group is input, I think. So here, in this group, we add this new parameter, 607C. This parameter is home offset. It means after the homing finish it, what the position will be set to the driver. Usually it's default at 0, because usually we set the home position at 0. Okay, and now you can see this parameter is display in this output group here. Oh, sorry, I didn't introduce. Here output means PLC outputs to driver. So this parameter is sent from controller, sent from PLC to the driver. And here, sorry, and here and here input means some parameter feedback from the driver to the PLC. So this parameter for PLC is input parameter. You can see, for example, this position actual value, torque actual value, or speed actual value. These parameter are all feedback from the servo to the PLC. Okay, continue. And here also in I/O mapping, we can see this home offset parameter. We find it now we need to create a variable in program and map the parameter to this object dictionary. This parameter is dint. So here we created a new variable and set the type of this variable as dint. And map it. So during the program running, we can change the value of this variable to change the object dictionary. Okay. So this is the PDO configuration. You can also configure other PDO other object dictionary in this same way. But you need to notice not all object is could be right. Some of them is read only. And for details, you can also check it in our server menu. And then last, I will introduce SDO operation. So here, these two instruction is SDO read and write instruction in 6V. And in Core 6, in 6C or in other brands PLC, they may have different instruction, different name to operate through SDO. And now we check this parameter. We have five parameter in this instruction. First two is the address of our dictionary object dictionary. And then the third parameter is the length of our object dictionary. And then the read device. And the last is the servo station, select station number. And for write is same. And now we can check this video. For example, we want to check, we use this same parameter, home offset. Okay, here this is the address of this parameter. The main index is 606C, and then the sub index is 0. And then the size is the length. The length of this parameter is 4. Okay, so now in instruction, we set the first parameter as the main index 607C, and set the different parameter as 0. We don't need to set. The third parameter 4, because the size of this parameter is 4. And this the third D6 means the reading value will be displayed in D6. And then last D8. D8 means the axis number. Here axis number is 0. So we don't need to set it. And for MC write SDO is same. For now, this parameter is 0. And we change it by variable. Here we change the value of this variable. And this variable, as we configured just now, we have already mapped this variable to the object dictionary by PDO. So after we change this variable, the home offset object dictionary will also change it. And also you can see here by instruction. By instruction, we read the value here. Here we change S20, and here we also read 20. And for write, here we write parameter 10. But you will see here, this 10 didn't write to the object because here have a note. When there is PTO configurates for some objects. Usually the SDO in this time you use SDO to operate it will failed because as we said here, as we said just now, the PTO have a higher priority. So when you configure, for example, configure parameter A in PTO, and in this time, if you use SEO to write value to this parameter, it will have question. So that's why we can't write value to just now. Okay, let's continue. DOST here, from here. Here we can't write it. So now I delete this PDO configuration. In here, I delete this parameter from our PDO group, and now we use SDO to check again. Set parameter. Okay. Now we set this parameter as 20, and we use SDO to read it. You can see here, we read 20. So it means we have write successfully. And then we can also here also try other parameter, 12. Okay, so now we can use SDO to read and write successfully. So this is the different way of PTO and SDO to transform data from master and slave. Here, as I said, PTO is usually used for some parameter needs high speed flash or real time flash, and SDO is just used to change some parameter, which we don't need to change all the time. So in program, it suggests, for example, here we use rising edge of M0 or M1 to change or rate parameter. Because if we use this normal colors, for example, normal colors content, this instruction will be executed according to the program cycle time. So I mean it will influence the communication between PTO. This is not what we want. So we are just to configure this SDO. Don't need to don't need to set many parameter by SDO to change it. Okay, and this is our today's contents. Do you have any questions? And later I will share the training video in our training group. If you have no time to no, but here in our presentation, I display how to say I show it by 6V. If you need, I can also show the configure it by 6C. Yes, in fact, the configured steps is similar. Maybe different PLC will have a little difference, but the steps is similar. Just the software interface is different. Yeah. Okay, and I think uh, yeah, I think can we have this video and also yes, I will send it to our training group. So if no questions, we can finish it our today's training. You're welcome. And our next training will be 2 days later, and I will introduce CSP control mode. Okay, thanks for attending. See you 2 days later.
乐团出问题了，
哦。
那边叶尚福现在在，我要过去看。